Hello, my dear students, and welcome to today's session. The topic of the day is time and motion, as you can see on your screens also. So, look at this picture given below. This is Sam. You can see on your screens also. Yesterday he woke up at 6 o'clock in the morning, and today he woke up at 9 o'clock in the morning. Will he reach the school on time? No, because yesterday he got up on time, but today as he got late, he would not be reaching the school on time. So children, as you know, time is very important. Everything has to be done on proper time. Okay, and for measuring time, the SI unit of time is seconds. Everything, whatever work we do, every day we are doing a lot of activities. Each activity has to be done on its proper time. Fine, children? So we'll start the chapter now. Can you all see on your screens also? Now, if we do our day-to-day task at a certain time, the knowledge of time is essential for doing our daily task. For example, going to school, boarding train, etc. Children, whatever activity we are doing, we are going to school, we have to be on time. In case we are not reaching the school on time, the school principal or the authorities will not allow us to enter the school. So everything has to be done on proper time. You all go to school. If you are late, does your school allow you to get inside? No. Sometimes you are punished or sometimes you are sent back. Why? Because you were not on time. So time is very important. Fine, children? So time can be defined as a measure of duration of events that take place and the intervals between two events. Every activity that we do daily depends on time. The amount of time taken to do a particular task depends on how fast we do it. Okay. What is our speed? Okay. How much energy we are using, how much fast we are doing. Okay. That depends upon the amount of time taken to do a particular depends on how fast we do, how much time we are taking it. Whether we are taking a lot of time, if we are taking a lot of time, that means we are doing the task slowly. If we are doing the given work at proper time, that means our speed was okay and we were able to finish that. Fine, children. Now moving to the next page. Why is there need to measure time? Why? What is the importance? Why do we measure time? So that a given task can be done in a proper way and at a proper time. So, if I talk about National Physical Laboratory, New Delhi maintains standard measurements of meter, kilometer, second in our country. There are many activities that we do in a day. Each activity needs to be done at a right time. That I told you right now also. Okay, whatever activities we are doing, it has to be done on a proper time. Okay. Now, in ancient times, people kept track of the movements of sun, moons and stars to detect time. Ancient Egyptians divide the day into 12 periods. But now, if I talk about the time which is right now going on, our day is divided into 24 parts. That means a day has 24 hours. But earlier during the Egyptian times, the time was divided into 12 periods. Fine, children? So there are many things which are helping us to know the time. First is, how can we keep the track of time? You can see on your screens also. In ancient times, people used devices like water clock, candle clock and hour clock to measure time. Okay, in ancient times, long back. But now things have changed. We are having watches, we have got wristwatch, we have got clocks, we have got smart watches. Okay, we are keeping the track of time with those instruments. Okay, earlier it was done with a water clock. Okay, then sand clock was there, then candle clock was there, and if I talk about pendulum clock, I'll read out for you. Then came the invention of clock. Before the invention of proper clocks, measurement of time was not accurate. Okay, sometimes it used to be early, sometimes it used to be late. But in 1656, Christian Huygens built an instrument called the pendulum clock. This device was much more accurate than the earlier clocks. Earlier clocks like water clock, sand clock and candle clock they used to tell, but the time duration was not always correct and accurate. But with the passage of time, things changed, and what happened? Pendulum clock was designed. It was much accurate than the earlier clocks which were used. Fine. Then it had a weight at its base as a time-keeping element. The main advantage of this device was it swung to and fro in equal intervals of time. Fine. It was based on the principle that time period was determined by the strings of pendulum, with wider strings taking more time than the narrow ones. But it had a disadvantage. A slight change in the length of the string that held the bob or mass due to thermal expansion altered the recorded time. This was when Mercury pendulum came into being. In this case, the weight was the container containing mercury. See children, earlier, as you can see on your screens also, pendulum clock is there. Okay. What happened in pendulum clock? This clock is there, and here, as you can see, a bob is there. I'm highlighting it. You can see this is a bob, and it used to move to and fro like this, to and fro. That way, it used to move and tell the time duration. Okay. Now come to the atomic clock. Can you all see on your screens also? The atomic clock was invented, which is very accurate. The SI unit of time is taken, which I told you, the SI unit. Everything has got a standard unit. Okay. The standard unit of time is second. Fine children. Now measuring of time using periodic motion. Okay. First of all, let me tell you what motion is. Motion means moving of a body. I'm teaching you right now and I'm standing still. I'm not moving. That means I'm not in a motion. Okay. An object is said to be in motion if it moves from one place to another. A moving object also repeats its movement over a certain period of time. If this movement is repeated within equal intervals of time, then the motion is said to be a periodic motion. See children, as I told you, I'm not moving. That means my body is in rest. I'm not moving. If I move, okay, if I'm standing here and I move this way, that means my body is in motion. Okay. Now, the measurement of periodic motion helps in knowing the accurate time. For example, of periodic motions are to and fro movements of a pendulum, the revolution of the earth in its orbit, etc. These movements are determined based on the periodic movement of the pendulum. Do you know what pendulum is? See, I'll tell you. Let me come to the next page. See, you can see on your screens also, this is a pendulum. Okay, what is it? A string is there. You can see the string is there, and on the one end, a metal bob is attached to it. Okay, and then this string is attached to some base, and now it keeps on moving. See, you can see, if I move it, it will go this way, then it will come back to its original position. Okay. So simple pendulum has a mass or weight in the form of a bob hanging at one end of a string. Okay. The other end of the string is held at a fixed point. A pendulum completes every swing or every oscillation in exactly the same time as long as the length of the string remains constant. That means if we are not going to increase or decrease the size of the string, the interval taken for a bob to move to and fro would be same. Fine children, when the bob of the pendulum is displaced sideways, it tends to move back to its equilibrium position. The combined effect of the restoring force and the mass of the bob causes it to go fro and about its equilibrium point. This movement of the bob from one point to another to its equilibrium position is called oscillation. The time taken to complete one oscillation is called time period. Okay. Now, if I say, you can see the spring is there and the metal bob is here. You can see here. Now, if we move it, it will go this way, then this way, and this way. This is called one oscillation. Okay. This is called oscillation. So the time taken to complete one oscillation is called time period. Fine, children? Now, please, you can see on your screens here also, units of time. You can see this table is very beautifully explained. Minute has 60 seconds, but then 1 hour is equal to 60 minutes. Okay, 1 day is equal to 24 hours. 1 week makes, in 1 week there are 7 days. If I talk about fortnight, many of you are very much confused what fortnight is. So 15 days, whenever we are talking about 15 days, that means it's a one fortnight. Fine, children? 1 month has got 30 days, but one fortnight has got 15 days. Fine, children? Then 1 decade is equal to 10 years, and 1 century is equal to 10 decades. 1 millennium is equal to 10 centuries. Fine, children? Please go through this table. This is very interesting and very informative also. This is really going to help you out. Fine. Now, see. Based on the discovery of this oscillatory movement came laws based on which the time period was determined. The law stated that the time period taken to complete one oscillation is independent of the mass of the bob. The time period taken to complete one oscillation depends on the length of the string used to suspend the bob. That I already told you. See, the time period in the first point, as you can see, the time period taken to complete one oscillation is independent of the mass of the bob. Mass means whatever the weight of the bob. It does not matter at all. Okay, time period will remain same. The time period taken to complete one oscillation depends on the length of the string used to suspend the bob. The length of the string will play a very important role in that. Fine. Then the time period taken to complete one oscillation is independent of the extent to which the bob is displayed sideways. If I take this bob till here or till here, it will not make a much difference because it is independent. Okay, to whatever extent we take it, it will not create any problem for time period. Fine, children? The time will the time would be same. Fine, children? So as the pendulum oscillates to and fro, the maximum displacement of the bob from its mean position on either side is called the amplitude of pendulum. Okay. With this periodic motion, accurate time could be known. The working principle of pendulum was used to make pendulum clocks. With this principle only came the existence of pendulum clocks. Fine. Now the next one. This is very simple to determine the time. This is an activity which you can go read on your own, and there is nothing much to explain in this. Okay, so you can just go through it. Okay. Now comes motion. Can you all see on your screens also? Okay. In our surroundings, we observe many things. Some of them are stationary and some are moving. Okay, बहुत सारी चीजें हमारे आसपास है. कुछ चीजें, some things are stationary, they do not move at all, and some things they keep on moving every time. So a body is said to be at rest if it does not change its position with respect to its surroundings. If the body changes its position with respect to its surrounding, then the body is said to be in motion. Okay, like I am teaching you right now, I am standing still and teaching you, so I am not in a motion, because with my surroundings, whatever things are around me, I am not coming near or far, I am not moving far from them. Okay, there are different types of motion now. See, first is rectilinear, circular, rotational and periodic. Rectilinear means I am moving in one straight line. Okay, this is rectilinear if I am moving in one straight line. Circular, like I am moving in circle. Fine, children? If I am moving this way. Rotational, okay, rotational if I am rotating, like the earth rotates, its movement is rotating. Then periodic motion at equal intervals of time. Fine, children? I'll explain you this. Objects may travel fast or slow. We may observe that aeroplane travels fast while car travels slow. This depends on the speed of an object. Okay. The speed of the object tells how much time an object is taking. So, now if I talk about versus uniform and non-uniform motion. What is uniform and what is non-uniform? If a body covers equal distance at equal intervals of time, however small the interval may be, then the motion is said to be in uniform. If a body covers unequal distances in equal travels of time, then this is called non-uniform motion. I'll give you an example. Suppose I walk 1 meter. If I walk 10 meters in 1 minute. Okay, first what I have done, I have walked in 1 minute, I'm covering 10 meters. Okay, now again if I am covering within 1 minute, I'm again covering 10 meters. Again 1 minute, I'm covering 10 meters. That means every time, distance is also same and time is also same I'm taking. But in case, if I talk about, this is an example of uniform. If I talk about non-uniform, I'm covering in first 1 minute, I'm covering 10 minutes. In second 1 minute, what I'm doing, I'm covering a distance of 20 meters. Then again, I'm got tired now. Again, in 1 minute, what I have done, my speed has, the distance is 15 meters only. That means in every time, what I am doing, my speed, sometimes it is low, sometimes I'm walking fast, sometimes I'm slow. That is an example of non-uniform motion. Okay. Now, if I talk about speed, I hope you have understood uniform and non-uniform. In uniform, the distance and time are always same, okay, every minute. But if I talk about non-uniform motion, sometimes I'm slow, sometimes I'm fast, sometimes I'm covering more distance, and sometimes I'm covering less distance. Okay, fine. Now, the next topic is speed. Can you all see on your screens also? Okay. Neha, Puneet and Nehmad lives in the same neighborhood. Okay. They also go to the same school. It is 1.5 kilometer away from their home. Neha goes to school in her father's car. Puneet goes to school on his bicycle. And Ahmed walks to school. There are 3 children living in the same colony. And the distance from their home to the school is 1.5 kilometer. One is going by car, another is going by bicycle, and the third one is going walking. So who would be reaching the first? The one who is going by car. Okay. So Neha reaches school in 5 minutes, while Puneet takes 10 minutes to reach the school. How long do you think Ahmed will take to reach the school? He will reach school faster than Neha and Puneet? No. Why? Because he is going on foot. Okay. This is because the distance covered by each of them is the same, but the rate at which it is covered is different. Hence, the distance covered or moved by an object or a person is called time. It is called its speed. And the SI unit of speed is meter per second. Meter per second. Fine, children? So, how do we calculate speed? The formula for calculating is speed is equal to distance covered upon time taken. Speed is equal to distance covered upon time taken. Fine, children? Now, there are different units of speed. Come on. Can you all see on your screens now? Okay. We know that the SI unit of speed is meter per second. Just now I have told you about this. This unit can be used to measure the distance run by an athlete. Okay. Have you seen an athlete running? Whenever an athlete runs, and whoever is on the finishing line always uses a stopwatch. The moment he touches the line, the stopwatch is pressed and you come to know the accurate time. Okay. On the tracks, what are we using? We are using a stopwatch because that tells us the accurate time now. It can be used to measure the distance covered by a motor car, but what do we do when we want to know the speed at which our trains, planes and buses travel? Hence, we use higher denominations of the unit. Why are we using higher denominations? Because here, when the athlete is running, he is covering a small distance. But when the aeroplanes, trains, buses, what are they doing? They are covering a long distance. So the denominations for measuring has to be higher. Fine, children? So we use kilometers to measure long distances, or we use miles to denote distance covered by planes. Time period that was earlier measured in seconds becomes hour. Hence, we can say kilometer per hour or miles per hour. Fine, children? The earlier, because the distance was small, so the denomination was small. Now, the distance traveled by these trains, buses, okay, different means of transport, the distance is quite long, so the denominations also go up. So now we are covering the standard unit becomes kilometer per hour. Fine, children? Now there are some practical problems are there. These are very simple. I'll explain you only one. See, Raghu walks 800 meters to school every day, and he takes 30 minutes. You have to calculate his speed. So I told you speed is equal to, what is the formula for finding speed? Speed is equal to distance traveled upon time taken. How much is there? Because he has walked 800 meters, you have to first of all make the you have to convert it into kilometers. So 800 meters are there, and 1 kilometer is equal to how much? 1 kilometer is equal to 1000 meters, children. So what we will do? We will divide it by 1000. Okay, fine, children. Now what we will do? We will distance traveled in kilometers will come up to 0.8 kilometer. Now time taken is 30 minutes. Okay, but time is measured in it should be divided by 60, because time taken in hours, 1 hour is equal to 60 minutes. That is why I have taken divided here. So this comes up to be 0.5. Now hence speed is equal to distance upon time. So 0.8 divided by 0.5, this comes up to be 1.6 kilometer per hour. Fine. You can go all through this. This is very simple. Okay. There is nothing much to explain. If you go through it properly, thoroughly, you won't be finding any problem. Okay. Now, okay. An instrument used to measure speed is called speedometer. All the vehicles, okay, they have a speedometer, because here we need to know at what speed these vehicles are running. Whereas the instrument used to measure distance is called an odometer. In case we are measuring the speed, then it has to be speedometer, and in case we are measuring the distance, it is odometer. Fine, children? Now, distance time graph. Okay, distance time graph. You can see on your screen. Okay. Now, there are various ways in which we can represent the data obtained after performing an experiment. These are the steps to represent data. First, we start by tabulating the data. Once tabulation is done, the data is plotted on a graph paper. Okay, a vertical line is drawn on the side of the graph. This is called x-axis. A line perpendicular to the y-axis is drawn. So if the graph forms a straight line, it is said to be uniform, and if the graph forms a curve at any point, it is called non-uniform. Okay, whenever you will plot the time interval and all on the graph, in case the line forms it in a straight line, that means it is uniform. Okay, and if in case the line is like this, it is non-uniform. Fine, children, I'll explain you properly now. Can you all see on your screens? Okay. See, children, look here. Here the x-axis of the x-axis of the graph is taken as time, and y-axis as distance traveled. Okay, if I talk about, this is x-axis and this is y. Okay, you must have earlier used this graph paper also in your maths and all, so you must be having an idea. The graph is actually divided into 4 parts: x, y, x complement and y complement. Okay, then On x-axis you will take time, and on y-axis you will take distance traveled. Okay. Now with this graph, now with its help, what are you going to plot? The points over there. So if I say in 1 minute, okay, in 1 minute how much distance is traveled? 10 kilometers. Okay, this is 1 minute, 10 kilometers. If I say in 2 minutes, how much distance is traveled? 20 kilometers. In 3 minutes, how much? 30. In 4 minutes, 40. So in every single minute, how much distance is traveled? It's 10 kilometers. Fine, children? So here, because the graph, when we are plotting this graph, the points, they are forming a straight line. That means it is a uniform motion. If in case it is not coming in a straight line, as you can see here also in the next graph, you can see on the next graph here, the time, if I say time in seconds, here, this is y-axis and this is, sorry, this is x-axis and this is x and y-axis. Okay. In first, you can see in this graph, you are going to plot how much time is there. In 1 minute, time in seconds, and distance traveled in meters. Okay, this is in meters and this is in seconds. Okay, so it is not in the straight line. You can see, is it in straight line? No. That means here the motion of the body is in non-uniform motion. Fine, children? So you will notice that the object travels unequal distance in equal intervals of time. Hence, the graph plotted will be a curved line. Such a graph is called non-uniform line graph. Fine, children? So some of the other graphical representation of data are pie chart and bar graph. You must have heard about pie chart also and bar graph also. Okay, in your math, when you keep on doing math. So children, I think this is all for today. Hope you have understood the chapter nicely. Take care of yourself. Bye-bye.